Hi, in today's video I'll be showing you how to calculate a t-test. To calculate a t-test, we must first introduce ourselves to what a t-test is. So, first we will be finding t-tests using the traditional approach, using pen and paper, and of course a calculator, and then we'll be finding the t-test value by using programming language, which is our language on terminal. What we can learn from this is the mathematical approach, and we can also learn the syntax/language for our language on terminal. So once we have this done, our steps are to calculate the mean and variance, and then we will calculate t-test value. Once we've calculated t-test value, we will calculate the degrees of freedom, which is the number of groups, which in this case will be 2, times the number of trials minus 1. Then we will check a t-value from the t-test table, and we compare the checked value with the t-test value. So our problem will be the effect of stress on plants on plant growth. So we have two groups, stressed plants and unstressed plants. We want to test if the two means of these two samples are statistically different. And if they're not, that is what our null hypothesis is. The two means are not statistically different. So first we will find the two means. We will calculate the means by adding the numbers together and then dividing it by the number of trials, which in this case is 10 for each group. So our stressed plant mean is 60, while our unstressed plant mean is 56. Once we have calculated the means, we will now find the variance, which can be found by the sum of the number minus the mean squared divided by the number of trials minus 1. So in this case, for the stress plant variance, we'll first start with the first number, 55. So what we do is take 55 and 55 minus 60, which is the mean, 55 minus 60 squared divided by the number of trials, which is 10 minus 1, plus the second number, etc., which gives us approximately 49.111 repeating. And then we will find our unstressed plant variance, which is equal to 54.888. Once we have everything, we can now calculate our t-test, which can be found by subtracting the means and then dividing it by the square root of the variance plus the other variance divided by the number of trials. So once we have substituted everything together, our first mean is 60, our second mean is 56, our first variance is 49.111, our second variance is 54.888, and the number of trials that we did for each group are 10. So that means our t-test is t equals 1.2403. Once we have found our calculated t-value, we will then find the t-test table value. So we will be using a two-table because we are testing for two means that are different, not larger or smaller. To find the t-test table value, we will find the degrees of freedom, which is the number of groups, which is 2, times the number of trials, which is 10 minus 1. So 10 minus 1 is 9, and 9 times 2 is 18. Our significance level will be 0.05. So once we input all our data into this table, we can round it out and we will find our t-test table value is 2.101. Our t value is 1.2403, which is less than our table value. Therefore, our result is not significant, or the two means are not statistically different, which means we will not reject our null hypothesis. Then we can learn how to use our language to find a similar result. So, to use our language, what we must first do is log into terminal. Once we have opened up terminal, we can type in the letter R capital and then enter. Once we hit enter, we will be entered into the program. So what we must first do is we must first put our two groups together. So x1 will represent our first group, which is the stressed group, and x2 will represent our unstressed group. So once we have this, we can calculate the mean by simply typing in mean x1, which gives us our mean of 60, and then we can find the mean of the second group, which is 56, by typing in mean x2. Then we find the variance by doing henceforth variance x1, and then we find the variance of the second group by doing variance x2. Or we can skip all of this and just write t.test x1, x2, which gives us a t value of 1.2403 as shown in our calculated value, degree of freedom of 17.945, which is very similar to our degrees of freedom, but this one's just more accurate, and our p-value is 0.2308, which is the calculated value from the computer. So with all this information, we can see that our t is still not significant, which means both the R language and our calculated value are not significant, which means our results are correct. So, thanks for watching. Remember to like and subscribe.